Hello everyone, welcome to another video. In today's video, I'm going to show you how to deploy a real-world AWS-based infrastructure via a Terraform-based Atlantis pipeline. So as I mentioned in my last video that I'm going to do a series of videos on Atlantis pipeline so that you are able to understand how to deploy a real-world infrastructure using this pipeline that uses Terraform. In my last video, I showed you how to set the pipeline and how to create some sample resources. But in this video, it's going to be a real world AWS based project that will be completely automatically deployed via this pipeline. All right. So this project I've already deployed in my previous videos as well. But at that time, either I used AWS Management Console to deploy everything from the UI, or I used a Terraform locally to deploy these resources. Okay, so in this video, it's going to be done via the pipeline. So if you are coming to the channel for the first time and this is your first time viewing any video on this channel, so I just want to brief you about the project itself. So as you can see the application architecture right now, it's basically a monitoring solution that you can use in AWS. And yeah, so how it works, so I'm going to explain that. So within an AWS region, it's going to be US East 1 in this project. In my AWS account, I'm going to have two availability zones. Within those two availability zones, you will have two public subnets in the VPC, and these two public subnets will have EC2 instances. Okay, that will be part of an auto scaling group. The auto scaling group is going to use a launch template to create these EC2 instances. The launch template is going to have a custom AMI or Amazon machine image. The Amazon machine image will have a web server configuration for HTTPD, and it will have a sample website code as well. So whenever that AMI is used in these EC2 instances, a website will be deployed via Apache web server. Okay, and this auto scaling group is also attached to an application load balancer. Okay, and so what we want to achieve here is that whenever the average CPU utilization of this auto scaling group, it goes over 40%, then a scaling event will be triggered, which means that I'm going to have a dynamic scaling policy configured as part of this auto scaling group. So it will be triggered, and what it's going to do, this dynamic scaling policy is going to increase the number of EC2 instances. Okay, automatically for us when the CPU threshold hits 40%. At the same time, this scaling policy is also going to trigger an email notification to my email via Amazon SNS or simple notification service. So in CloudWatch, we are going to configure an alarm. Okay, and that alarm is going to trigger the email. Okay, and scaling event is also going to create a new EC2 instance as part of the dynamic scaling policy. Okay, so this is like a real world monitoring solution that you can deploy in AWS via CloudWatch and SNS and other services that I just spoke about. Okay, so this is what we are going to deploy. Now let's come back to Atlantis. So this is the pipeline that I have. It uses a Terraform behind the scenes. So it's going to first show me the Terraform plan output, that what resources are going to be created, modified or destroyed, and then when you apply, it's going to apply that plan for you. Okay, so here I'm using an EC2 instance where I've configured everything that I need for my Atlantis pipeline. The setup I've already showed you in my last video. If you want to configure this type of setup on your laptop, you can check my last video, or I'm going to put the link of that video in the description of this video. Okay, so yeah, so and in terms of resources or in terms of the Terraform configuration, what I'm using, I'm going to show you that as well. So here I am on my Visual Studio Code IDE, and if you see in main.tf file, if I run through, so we'll have a launch template that will be attached to the auto scaling group. So I'm going to pick the name from the locals.tf file. Okay, so if you see locals.tf, I have local.project underscore name. Project underscore name is called demo here. Environment is going to be dev. So these values are going to be passed here for the name of the launch template. Then image, what AMI I'm going to use, instance type, key name, interfaces. I'm using some variables as well. As you can see, I have a variables.tf file where I've defined all these variables. Launch template is going to have 8 GB of elastic block store. It's going to have an IAM role as well. Okay. Then I'm going to use some additional tags. Once again, I'm going to use the locals.tf file to pick the tag values. Then scaling auto scaling group, I'm going to define its name. Once again, it's coming from the locals.tf file. Minimum size, desired capacity, maximum size. The subnets that will be used to create EC2 instances as part of the auto scaling group. It's going to come from a variable for subnet IDs. Launch template I already defined in my a previous configuration, so it's going to be picked up from there. Then again the tax information. Similarly for application load balancer, I'm defining everything. The type of load balancer, it's going to be an application load balancer. The security groups, it's coming from the variable. Subnets also I have defined in variables.tf file. Tags, then I'm going to create a target group as part of the load balancer configuration. What port, protocol, and VPC ID I'm going to use. The target type, because we have IPs as well for containers, but in this case it's going to be an instance. Target type. Then a listener configuration I'm defining here. Port, protocol, and other things that it needs. An auto scaling attachment. So our load balancer target group is going to be attached to the auto scaling group. So that resource block is defined here. Then our dynamic scaling policy. Okay. So here I'm defining that all the things that we need as part of our scaling policy. Here I'm defining the CloudWatch alarm configuration. Okay. Where I'm defining the average CPU utilization as the threshold value. Okay. So all that is defined here. Then SNS for notification services. This is the exact resource block where I'm defining its name, and name once again is coming from the locals.tf file, and this is going to be the display name of the SNS alert. And in SNS you create a topic to which you create a subscriptions. So this is the block to create the subscription for the topic. So here I'm going to use one email. So I'm using this environment variable notification underscore email. It's going to have my email ID, which for to which this SNS notification will be triggered to. Okay, so this is the project. In terms of a Terraform code, I just wanted to brief you about what resources we're going to create here. If you still have any doubts related to any of this code configuration, you can reach out to me in the comment section and I'm going to answer all your queries. Okay. All right, so let's start the demo. So I'm on my EC2 instance where I've configured Atlantis setup. So all the files are copied to my EC2 instance from my local IDE in Visual Studio Code. So these are all the files, and I'm going to provide these files to you also, so that you can try these in your laptop, and you can make changes as per your need. Okay, just remember that in variables.tf I'm using some default values, okay, with each variable. So these values will be different for you because this is the VPC ID from my AWS account. This subnet ID is the security group's AMI ID. So you have to change these accordingly. Okay. This a key pair also. So these values have to be your account specific. Okay. So just ensure that you have made the changes to these values, these default values, only then it's going to work for you. Okay. Rest you can keep as it is. Okay. So what I'm going to do is, I'm going to make a test change because I've already tested this setup once. So I'll just make a test change so that we are able to see whether it's working for us or not. So let's just, I'll just write this. So I'm making a change so that I can trigger the pipeline again. Okay. I'm using this branch called AWS. So I'll add this file variables.tf. And I'm going to push the change to the repo. Okay, so please get a new branch. Okay, you can use the same branch AWS in your repo, or you can name it anything else. So create a new branch and then make the changes to the files and then add and commit. Okay, so this setup again I showed already in the last video where I have covered everything step by step. So I'm not repeating a lot of things here because it's already covered in my last video. And I'm going to put the link of that video in the description of this video so you can refer to that. So yeah. So it's going to push the changes to my repo, to my Atlantis pipeline basically. So here I am. This is the merge request that was already created. So I'll just hit refresh once. And you can see the pipeline has started to run. Okay. The pipeline has passed, as you can see. Okay. And in the comment section, you will see the output just now. Okay. So this is the output. So Atlantis ran a plan and it says 10 to add, 0 to change, 0 to destroy. Okay. If you click on this drop down of show output, here you can see all the details in much more. You can see all the information in much more detail. Okay. So to apply the plan, you just have to comment this Atlantis apply. So you can copy this and put it here. Hit comment. And it's going to start your Terraform apply command basically. Okay, so we'll just wait for this to trigger. I'll just hit refresh once. So the pipeline has started to run and there are a lot of resources that it needs to create. Okay, 10 resources. So I'll just come back when the pipeline finishes to execute and create all the resources. So the pipeline has finished successfully and it has deployed all the resources. It has created all the resources. So you can check the output also. Run apply and show output detail. You can see all the different resources that were created as part of the Atlantis apply command. Okay. So now we can verify everything in our AWS account. So I'll go to my AWS account and I'll verify the resources. So I'll go to EC2. You can go to Auto Scaling Groups. And this was the Auto Scaling group that I used, demo-asg. Okay. And you can click on it and you can see it was created successfully. Scaling limits, minimum and maximum, all came from Terraform. The desired capacity was set to 2. Instance management, you can see 2 instances running right now. If you go to automatic scaling, you can see a scaling policy also. It was created via the Terraform code itself. Okay, so yeah, here instead of 40 as a threshold, I'm using 25 so that we can trigger the alarm a little bit quicker. Okay, so that's what I have done. Okay, so here I'm using average CPU utilization of the auto scaling group as my metric threshold. Okay, this is working fine. I can go to CloudWatch as well. In CloudWatch, you can see the alarm that was created as part of the configuration. You can go to alarms, all alarms, and here you can see a demo CPU alarm. So it was just created. Okay, just now. Okay, so it's working fine. Now if I go to SNS, I can check the notification topic that I created, to which my email has subscribed as well. This was the topic. Sorry, this is the topic, demo CPU topic. If you click on it, you can see the subscription also. It's in pending status because I haven't confirmed it, so I can check my email as well. Here you can see I received the subscription confirmation. So I need to confirm the subscription once on my email so that I can receive all the alerts. Okay, so I can click on it. I can click on this URL and it's going to confirm the subscription to that SNS topic. This is done. Okay, so now if I trigger any if any alarms are triggered, I'm going to receive an automatic email on my email ID. Okay, after I confirm this, so everything is looking fine. Also you can check the load balancer as well, and auto and the launch template as well. So let's check that as well. So I'll open load balancers. So demo will be there in the name because that's what I used. You can see demo ALB created, and there's a target group also created. If you click on this listen and rules, or you can click here, it's going to open the target group called demo-tg. So everything is configured correctly. Okay, right now it's unhealthy, but we'll just see that part as well. This is done, and if we click on launch template, so here you can see demo-lt is the launch template that was created. So yeah, so all the resources have been created successfully. Okay, so you are seeing these targets and as unhealthy because I'm not using a custom AMI in this demo, because the point of this demo was to show you how you can use an Atlantis based Terraform pipeline to deploy the resources automatically. Okay, so if you use a custom AMI with that web server configuration, so all this I have already covered in my earlier video where I've created this project. Okay, so there I've shown you how you can create a custom AMI with custom application code and the web server configuration. So if you use that AMI, if you use a custom AMI with this configuration, then you will see these two health status as successful. I've also showed you how you can trigger this uh, scaling policy. Okay, so we are using a scaling policy. Let's go back to auto scaling groups. So in this, I have a dynamic scaling policy configured. Okay, it's going to trigger each time your average CPU utilization of your auto scaling group goes over 25. It reaches 25 or it goes over 25. It's going to add one instance to your auto scaling group. So auto scaling group is going to change the instances from 2 to 3. Okay, so this demo I have already showed. This demo I've already showed in my earlier video. Once again, I'm going to put the link of uh, that video as well in the description of this video, where I've shown how you can simulate CPU utilization on one of the EC2 instances, and then it's going to trigger the SNS based notification to your email ID, and it's going to trigger the alarm as well. So all this I've already covered, so I'm not repeating it because the motive of this video was to show you how you can use Atlantis based pipeline to deploy all these resources, okay, without you having to do anything on your local laptop. So that was the whole point. But anyways, if you have any issues, any concerns, or anything you want to ask related to the this entire architecture or the Atlantis based pipeline or the code that I'm using in Terraform, you can reach out to me in comment section and I'll be glad to answer all your queries. So this is about how to deploy. Now how to destroy the resources also. For that, I'll go back to my Atlantis pipeline, and here, so this one documentation also that I've created, how to use Atlantis based pipeline to create and to destroy resources as well. So I'll just go to my GitHub repositories, and So if you scroll to the very last, you will see a command that you can use to destroy the resources as well. Okay, so to destroy, this is the command. So you can just copy and paste. So it's going to first plan, because you have to create a plan first. Okay, only then the apply works. So you have to create the plan first. For that, you can comment this and it's going to create a plan. It's running. The pipeline has passed. Okay, and in the comment section you can see now the plan is 0 to add, 0 to change, 10 to destroy. Okay, in the output you can see what all resources are going to be destroyed. And to apply the plan, just run Atlantis apply once again in the comment section. So you need a plan first, only then you can apply the plan using Atlantis apply. That's how this pipeline works. So apply is going to trigger the pipeline again and it's going to destroy all the resources for me. So this is how you can completely automate the creation and termination of all the resources via this pipeline. The pipeline has started and it will take a while because there are a lot of resources it needs to destroy. So I'll come back when it's done. So the pipeline has passed and it has terminated all the resources that I created initially. Okay, as you can see in the output also, what all resources have been destroyed. Okay, so everything has been destroyed, and if you go to your AWS account as well, you won't see. Alarm is gone. Go to topics. This topic will be deleted as well. Okay, auto scaling group demo-asg. If you go here, okay, so demo-asg gone. Target group also gone. Okay, it's not there. And auto scaling groups also, it's gone. Demo-asg. So yeah, okay, and instances also you won't see those instances. Okay, so yeah, it's working as expected. So this is how you can completely automate the creation and termination of resources via a pipeline which uses Terraform behind the scenes. Alright guys, that's all I wanted to cover. I hope you liked the video. If you did, I request you to please hit the like button. Please share this video with others and please do subscribe to my channel. Alright, that's all for this one and I'm going to see you in the next one. Bye for now.